Hey guys, Chris the IT Warlord here again. We're continuing on our CCNA 200-125 newest version, how to pass it. So we're just going through the Cisco's topics, step by step. And if you guys have any questions, email me. Wyld125@gmail.com, WYALD125@gmail.com. So I have, our last video was on TCP/IP and OSI model basics. So now we're going to look into comparing TCP and UDP and looking more into the TCP/IP model. So here's the transport layer. This one's really important. It's layer 4. Remember, please do not throw away sausage pizza. The two most commonly used transport layer protocols, TCP and UDP. TCP is Transport Control Protocol. It's connection oriented and it's considered reliable. The reason why is because it provides error recovery. UDP stands for User Datagram Protocol. It's considered connectionless, and unreliable. That doesn't make it doesn't make it worse than TCP or anything. You can't compare the two. They're used for different purposes. UDP is usually used for real-time applications such as voice, video, things that can't go wrong if you lose a packet or two. So here's a little transport layer communication here. Now I'll talk about that later. Let's jump into this. TCP IP comes in A10. So A, application, T, transport, I, internet, N, network. Right? Yeah. So application layer provides services to the application software running on a device. So it'll run the GUI, the graphical user interface. It does not define the application itself, but it defines the services that the application needs. Now that means that it does not define, so I open a web browser, it's not going to define, the application layer of TCP/IP is not going to define a web browser. It's going to define HTTP or FTP or some sort of protocol that's down underneath what we normally see. So here's some HTTP GET. So that's a request to a server. And then you get a reply plus a data only message, which is probably going to be an index page if you're authenticated and you find the web page right. It's going to be an index page, meaning the first page you come to on a URL. So if you get an HTTP 200 code, that means you're okay, you're cool. Your connection is established. HTTP 301, that means the site is moved permanently. HTTP 404, requested URL not found. I'm sure you guys have probably seen that one before. It's pretty common. The transport layer, again, TCP, Transport Control Protocol, allows two hosts to establish a connection and exchange streams of data. The TCP header and a UDP header, whichever protocol is used by the application or higher layers. Now what happens is the application PDUs, application layer PDUs, they drop down to that transport layer and they use transport layer as a service, and that transport layer adds a header, and that header is used to track, which device, which application. Say you have two web browsers open, it's going to number those. It's going to have a checksum, and it's going to have those sequence numbers. So if for some reason data is lost, it knows which number it's missing and how to get it back. It'll request another one. So TCP error recovery basics provides a service, one being error recovery. TCP guarantees the delivery of data across a network. Acknowledgements allow the error recovery. Acknowledgements allow it's the handshaking protocol. So it's a SYN. So I'm synchronizing, and then if I'm acknowledged, then I send a SYN-ACK. So it's a hey, what up? So that means a connection's established. So in UDP, you're not going to have that. That's what it means by connection oriented. UDP, you will not see that. SEQ, sequence number, those are included in the TCP header. The segments are equipped with the TCP with the sequence number to allow higher layers to know which order the data should come in, 1, 2, 3, etc. This means that if a segment is lost, the TCP header will provide the information needed to request the segment again, which is error recovery. These are important. Same layer interaction on different computers. These are on the tests for sure. Same layer interaction means that the two computers are going to use the same layer. So we're going down, right, and then coming back up when we're communicating. Same layer. So transport layer to transport layer is what that means. Same layer. To communicate with the same layer on another device. Header information added by a layer. The sending computer is processed by the layer of the receiving device. Yeah. So adjacent layer interaction, this is just as important. They look at this now. On a single device, one layer provides a service to a higher layer. The software or hardware that implements the higher layer requests that the next lower layer perform that needed function. So basically what that means is, so application layer uses transport layer. Application is layer 4. Layer 3 is transport layer. Application layer uses transport layer to provide it with error recovery to make their service, the application service, better. So let's say a web page, if you're having packet loss, it's going to be slow. If you're using a video game, packet loss, you're going to have a slow, you're going to have lag, spikes, all that good stuff. Bad stuff, not good stuff. TCP examples, so we have HTTP, hypertext transfer protocol, yeah. TCP port 80. And then you got POP3, which is for sending mail. It's an older protocol. It's TCP port 110. I put World of Warcraft on here, TCP or UDP port 3724. So those are just examples of port numbers. Port ranges are 1 to 65,535. These are assigned by IANA, or the Internet Assigned Numbers Authority. Ports 0 to 1023, are well-known ports. You can Google all these or get them from that cheat sheet site that I put in one of my previous videos. Ports 1024 to 49151 are registered ports. Vendors use these for applications. Ports over 49,151 to 65,535 are dynamic or private ports, and we'll find out more about those later on. UDP, User Datagram Protocol. It's used by programs running on different computers on a network, send short messages called datagrams instead of segments. Instead of TCP segments, we got datagrams. It's unreliable, connectionless protocol. Simple connection results in faster speeds of transmission because you don't have those handshaking and all that other good processes. It provides checksums for data integrity, but no error recovery. It has port numbers to keep track of which application and whatnot. It's considered unreliable and connectionless. Doesn't necessarily mean it's no better. I just mentioned that. It just means that there is no guaranteed delivery of segments. Ordering or duplicate protection. Used for time-sensitive applications such as real-time applications, voice and video. Common UDP, DHCP, UDP port 67 and 68, DNS. That's a good example. DNS is actually TCP and UDP. It's the only protocol that really uses both, and it's on 53. NTP, Network Time Protocol. It's UDP port 123. And Network Time Protocol, all it's doing is just pushing out the time. If it misses time, it's going to click it back in the next second. Not something that you need a handshake for. Here's a UDP header. There's just a little example of one. The layer 2, network layer. So this is the IP layer. This is where routing happens. Internet protocol provides several features. Most importantly is addressing and routing. Comparable to the postal service, uses addresses and routes to get mail and packages from a source to a destination. Just like that. IP version 4 example is right here. There's another example. That's what they look like. IP version 6, which we'll get into later. This is what those look like. So those aren't too scary. Those look scary, but once you get the hang of them, they're not too bad. You can find out your IP address by doing any of these commands, whatever operating system you're using. If you do Windows key R, CMD, enter, and then type in IP config, you'll find your IP address. There's also other ways to do it. Here is a example of a small, I wouldn't say corporate network. I would just say a small network. Looks like a little Soho or small home or office network. Network addresses are compared to zip codes. So like router knows to send to a certain network, but he doesn't care where the address is at because the postal service in town will handle that. That's the local router or the gateway, the town one. He handles the host addresses. The network addresses, just like the zip codes. IP host, any device that connects to a TCP IP network. IP routing, process of forwarding an IP packet through one or more routers or gateways. Link layer protocol, or link layer, which is layer 1. Data link plus physical. So link refers to the physical net connections or links between two devices and the protocols used to control those links, such as Ethernet. I'm sure you heard of Ethernet. Routers use the data link layer, hardware addresses, to send to the next router when forwarding. Ethernet protocol, or IEEE 802.3, encapsulates IP packets into Ethernet frames with Ethernet headers and trailers, MAC addresses, and error check CRCs. Example MAC address is right here. These are always 48-bit hardware addresses. The first half of them, so the first 24 bits, or 6 characters here, 6 hexadecimal characters, are OEM, so HP, Dell, Cisco, whatever. Second half is always unique. After a packet is encapsulated into an Ethernet frame, it can then be transmitted in bits, or zeros and ones, electrical, light, microwaves, whatever. Some sort of physical transmission can take place to that destination MAC address. So there you see we go layer 2, layer 1, and then we come back up, layer 2, or layer 1, layer 2. So, and then it keeps going up. So right here I put a good list of all the TCP, or this is actually the OSI, which devices it uses, all that good stuff. So if you want to pause the video and take a look at that. These are talking about, well, I'm running out of time, but anyway, questions, wild125@gmail.com. Like and subscribe. Thanks, guys.